Hey, Gen Chem kids. We are here for another quick lesson and homework assignment. I'm going to not really film the demos this time. I'm going to find videos to put so that you can watch them so that it doesn't get so caught up between demos and taking notes. I hope that will go smoother. So experiment with me today. So today we are going to talk about physical and chemical changes. And so we're going to talk about chemical changes first. Chemical changes of matter involve the rearrangement of atoms. Okay, so we are rearranging the atoms. That means you end up chemically with something different than what you started with. So let's take a reaction that you should be somewhat familiar with from biology last year. Let's do photosynthesis. So in photosynthesis, we are taking carbon dioxide, we are taking water that the trees and plants also take up. And when we are done with that, this is my reaction arrow. It's a pretty sad one. We end up with glucose and oxygen. Okay? So notice we still have the same things. Let me change the color of my pen really quick. We still have carbon, right? That didn't change the color of my pen. We still have oxygens showing up, and we still have hydrogens showing up, but notice they're not arranged the same way. So carbon, instead of being bound to 2 oxygens here, carbon is bound to 6 oxygens with 12 hydrogens as well. And hydrogen bound to just oxygen here, hydrogen is bound to carbon, bound with carbon and oxygen. And here oxygen is also by itself, and here on the left-hand side, it's not by itself at all. So, burning methane. I just want to write the equation for you. I will find a video with a demo. So burning methane, you guys know that as natural gas. So when we heat our houses in the winter or our homes in the winter, most of us are going to have a furnace that burns natural gas. Natural gas is primarily methane, which is C with 4 hydrogens. And when we burn that with the oxygen in the air. Okay, so we're going to burn that with the oxygen in the air. And once we're done burning that, we get a lot of heat. So I'm going to put heat here because that definitely is something that we get. And we get carbon dioxide and we get some water vapor. You guys probably don't recognize that we get water vapor because it's in the gas state. We don't get liquid water. But sometimes if you pay really close attention, you'll see that there's a little drainage hose on the far end of your furnace that might go to a little drain in your utility room if you've paid attention. So that is the reaction. Notice carbon is bound with hydrogens here, but here it's bound with oxygens. And oxygen's by itself here, and here oxygen is with carbon and with hydrogen. So we've totally rearranged the molecules. So when we have a chemical change, we end up with something totally different than what we started with. Okay? All right, let's go on to physical changes. Physical changes of matter do not involve the rearrangement of atoms. Okay? That means that you end up chemically with the same thing you started. For example, if I melt ice is really just water in the solid state. So I'm going to put an S here for solid. And if I melt it, I just end up getting water in the liquid state. It's still H2O, but what has changed is the state or the phase, solid to liquid. So melting, boiling, condensing, All of those are just changes of state. I'm changing things physically, but I'm not changing things chemically. Okay? Chemical and physical changes are accompanied by energy changes, and I showed you that here. In order to burn that methane, I'm releasing a lot of energy. So a lot of times we will have energy changes. In order to melt this ice here, I'm going to have to put some heat in here to make it liquid. So we do have energy changes as we go through here. Sometimes energy is required, sometimes it is released. So, of course, in chemistry, we have a word for when it's required and a word for when it's released. So endo means within. So if I have an endothermic change, that means energy is required. Okay, so that means I need to heat that reaction before it will go. So I need to heat up this reaction for it to go. Sometimes if I just feel the side of a reaction that is endothermic, it will feel cold. It will feel cold because it is absorbing the heat from the surroundings to heat up the reaction. Okay? So when we get to class, I'm going to try and do ammonium nitrate dissolved in water. If you've ever had one of those first aid cold packs where you have to kind of break the reservoir and shake it up, you know what I'm talking about. This is what they used for the cold packs. It gets cold really quickly. Okay? Exothermic is the opposite. Exo means outside of or without. That means energy is given off. Okay? So this reaction releases heat. So it is going to feel hot or warm. Okay? So for example, if I create some hydrogen gas, which I can, and I burn this in the presence of oxygen, I can actually make water. This will give off heat. This will be warm. Okay? So let's go on to the elements. Regarding elements, let's see. There are over 110. There's 92 that occur naturally. So I just want to start prefacing you on the elements. We're going to need to learn several of these throughout the year. So I'm going to link some Quizlets that I have done to your chemistry page so that you can start learning these elements that I expect you to know. We'll go over some of these elements and these symbols next time. And next time we will start really going into it, and probably next week we will start giving you quizzes on these elements. I have another video that I want to also give you that is kind of a review of chemical and physical and classification of matter. I will also link that in your notes today as well. Thanks. Have a good day. Bye.